Just out of the Toll Memorial area above Rock Cut, and off the distance we have a nice close-up of Long's Peak. But that's not what I wanted to show you here at this time. Let's take a look at some of the unique and interesting rock units that form part of this part of Rocky Mountain National Park. So you can see we got some interesting ledges of sedimentary rock, or what used to be sedimentary rock, and granite rock. Let's take a look at this. Out in the sunlight here you can see several rock types. The light colored one you can see in the foreground there appear to be two veins actually of light colored rock of granitic composition. It's something we call pegmatite, and that is part of the original Earth's crust that had been formed prior to the flood of Noah. If we look at the dark colored rocks, these used to be ocean bottom sediments. How do they get that way? Well, it just so happens that there was a lot of water caused by a big flood that came through this area, and as a result, sedimentary rocks that we know as sandstone, siltstone, shale formed, and were eventually, under tremendous heat and pressure conditions, elevated many thousands of feet above sea level that we see today. Right now, this ocean bottom material that we see, or what used to be on the ocean floor, is now 12,300 plus feet above sea level. And because of that, we can conclude that there was a tremendous mountain building episode that took place here, not only squeezing these sediments under tremendous pressure and friction, but also adding heat from inter-earth sources, sources of heat from within the Earth's mantle that migrated up through the crust and caused unusual and indeed beautiful contortions of these rocks. You may notice here that the schists in the foreground seem to have a glisten to them. They have a beautiful reflectivity, and that reflectivity is probably due to a common mineral known as muscovite. Muscovite forms in all kinds of different geological environments, but if you can see any shimmer or shine on those rocks, that indeed is muscovite. Let's take a look over here, maybe get a little better look at that. Quite possibly there, you might see one as well. So the earth was upturned very violently during the flood, and eventually, after the tremendous undersea devastation took place, we had tremendous uplift. In the western United States, the uplift may have been caused by a combination of events, things like that, such as mantle plumes from within the Earth's interior. Excuse me, I guess we got a little bit rowdy there, but we'll try to continue on. Within the Earth's interior, that would force much of the land masses thousands of feet above sea level. Also, there was compression, that is kind of like a collision type of activity that took place, and when that happened, we had uplift from that as well. So a combination of collision and uplift beneath the Earth's surface from the mantle caused by mantle plumes, which are also expressed, by the way, in the form of what we saw back at the previous stop at lava cliffs. There was a breakthrough from through the Earth's crust from the mantle, and we see expressions of lava on the surface back there. Once again, looking back towards the Front Range and Long's Peak, and the peaks that make up that group include Long's Peak, and to the right of it, Pagoda Mountain, Chief's Head, and Mount McHenry. To the left of Long's Peak is, just barely see that, is Mount Meeker. So let's go ahead and continue our trip through Rocky Mountain National Park. Get some more beautiful views of this incredible, wild place on the Earth's interior. Oh, excuse me, in the Earth's continental United States, in the western United States. Beautiful spot indeed. Hope people come to see this someday and enjoy the scenic wonders of Rocky Mountain National Park. Good day.